Hello. Today I have something very special to show. Uh, it's kind of been in the works for a while, about almost a month, and it is a active lag detector, not lie detector, lag. Um, and you might wonder, oh, this sounds pretty interesting. How does it work? Well, um, I actually stumbled across, well, this quote unquote phenomena on accident. I was mm, um I was building a machine, and well, so that I could launch projectiles and just objects consistently and accurately, so I could try to study like high speed collisions and things that wouldn't rely on stuff like thrusters or potato guns where the mass could become an issue. And um, I set a timer on it so that after it started spinning, it would release the object, and it would go flying across the world, and I would drive out, and I would like mark on the ground where it hit. And I noticed that every time I fired it, wherever it landed would move slightly to the left. Every single time. About 2.5 blocks. And I thought that it might have something to do with the amount of objects that were in the world. So I got rid of some of the other projectiles that were lying around, and it moved to the right instead of the left. It moved back. And I thought, what if it's dependent on the amount of objects there are in the world? So I loaded in one of my old aircraft. If I can spell it. This one. A couple of these on top of each other. Because it's pretty laggy-ish. And the projectile went nowhere near where the others landed. And I have a theory as to why this is happening. Well, I came up with a theory, and that's the time step of the game. So like the more objects there are in the world, of course, the more objects the game will have to process every time step. And this would be considered as like micro lag, like calculations the game is making that slows down the game, but not to the point where the player can perceive it. Your game can run anywhere between 60 FPS and 120 FPS, and it still looks pretty fine. Now, for things like logic gates, they all have to interact, one after the other every time step. And I'm not sure exactly what the delay is, but I'm assuming it's just, if you have a really fast timer, it will change its state every time step. Now, for a moving object, if say I wanted to go from here to here in say 1 second, and there were 60 steps in that second, I would have it would take 60 individual calculations of its location in that 1 second that I perceive. Whereas if it's running slower, if the time step has to go slower, say to the point where it only has to process it 20 times, it will still move the same distance, albeit the distance it travels between each time step has increased to make up for that. And there should be a critical point where there's a cutoff, where there's like a maximum that it can travel, and that's when you start to get lag that you can perceive, when the frame rate is going below 12 frames per second. And so the logic gates, they can't make jumps like that. They can't just, like, if you have a chain of logic gates, it can't just go from like 1 to 3, because there might be like a NOR gate or a NOT gate or somewhere in there that it has to deal with. And so there's the consistency, well, quote unquote consistency of a moving object, and then there's the heavily time dependent logic gates. And I was thinking that if you had, say, a clock produced by a moving object, it would be consistent up until that critical point. Whereas the logic gates, the time would slow down. And now, I mean, obviously, the machine that I first made would technically be a working lag detector, and a quite sensitive one at that it could tell, that it could show the amount of difference that just a single object in the world could make. But the problem was, every time I used it, it's like a minute and a half to, slow it down, reload it, and set it up again for the next fire. And plus it leaves 2 objects in the world every time I use it. Now, to make one that doesn't fling objects everywhere, that was really, really, really hard. I can try to talk about those other revisions. There were like 6 other versions until I finally got into this one. So the giant thrusters on the end, these will always stay at their terminal velocity of, I think, about 6,000 blocks per second. It's a little bit above that, like 6,200. And yeah, obviously, since it's at a really really large diameter, the RPM will be pretty low. And this is good for the detection part, so I can get a consistent signal. Now this, it sends a signal bouncing back and forth through here, and then every other time it goes around, it just goes to an AND gate of its corresponding location. And by looking at which ones are lighting up and where, I can get a rough idea as to the lag in the world. Now, this isn't really ideal because it's not like a nice and clean number to look at. It's just a bunch of points. But it is certainly an effect that can be noticed. If I get a couple of these, or just that one alone, you should definitely, you can tell there's a big difference. That one was not lighting up before, and this one wasn't. And if I get rid of it, then those should not be lighting up anymore. Yeah, and I mean, there are some small things you can change, like you can put like a peg in front of it to get a somewhat higher accuracy. You can change how the rest of it's being activated, and I'm still kind of experimenting with these settings to try and get good, clean results. And now I will say that this is working, and this is still kind of like a prototype. I might try and come back to the earlier design, since that worked so well, and I don't know, try to make it so that it doesn't leave objects everywhere. But having the things like the time step and position on my mind, I've theorized a machine that can manipulate kinetic energy um, and produce vectors without things like thrusters or potato guns required, and nothing to react against. I will not be I won't be telling what my theorized device is yet. It's just a theory. Um, and as of now, I have high hopes in this project. And I'm interested to see what maybe some of you think.